So let me break down this chart for you. This is your earthquake, P wave, and S wave travel time chart. So if we look at our x-axis down here, this is the epicenter distance times 10 to the third. So what it really means down here is this is not just one, this is 1,000. This is 2,000, 3,000, so on and so forth. So what these little lines go up by are 200s. So this is 1,200, 1,400, 1,500, or 1,600, 1,800, 2,000, 2,200, 2,400, 2,600, so on and so forth. Okay, so this is the distance. Over here on the y-axis, we have the travel time. So here's minutes, because it says we're going up by minutes. So each one of these has two little lines separating them. Those go up by 20 seconds. So here's 20 seconds, 40 seconds, 1 minute, 20 seconds, 40 seconds, 2 minutes, and so on and so forth all the way up. Now, if you notice, drawn across the middle of the whole entire chart, you have the P wave here. So this is the P wave line, and you have the S wave line. And if you notice, the P wave line will go farther faster versus the S wave line. Because remember, we talked about P waves are primary and they get there first because they're faster. S waves are secondary, they're a little bit slower, and they get there after the P waves. Okay, so that's how we break down this chart a bit. All right, so this is if you are looking for the distance of the earthquake. If you are looking for distance and you are given the P and the S wave arrival times, I know that's kind of hard to see in this, but you should already have it written in your notes. It says subtract the time, then you use the paper method. And that's what I'm going to teach you right now is how to do the paper method. So overall, the direction you really want to pay attention to is if you are given the P and the S wave arrival times, you're going to subtract them and use the paper method. So for the first question, it says the P wave arrived at 1:30 in the afternoon, and the S wave arrived at 1:04:30 p.m. at Cambridge. What is the distance? Well, when I subtract time, I have to make sure I put the later time up top first, and then I put the time that was not as late here, and then I'm going to subtract them. So 0, 0, 0, 4 minutes total. So it was 4 minutes. So what I'm going to do is now the paper method is I'm going to take my scrap sheet of paper. I like using a half piece because it doesn't get in the way as much. Because if you use a full piece of paper, it's kind of bulky and gets in the way. So what I do is I line it up on the side of my reference table here so I can see all of the times. I mark where 0 minutes is, and I mark where 4 minutes was, and then I'm going to take these two lines, and I'm going to keep my bottom line on this P wave line here. I'm going to keep that vertical, and I'm going to follow this up until I get and I reach right about there, where this little line stays on the P wave line and this little line reaches the S wave line. And what I'm going to do is I follow it straight down to see what the distance is. And it goes up by 200, so 2,200, 2,400, 2,600. So for this first answer, it should be 2,600 kilometers. Check my answer. Woohoo! I got it right. Okay, so for the next one, it says the P wave arrived at 3 p.m., so that's my later time, so I'm going to put that down here. And the S wave arrived at 3:05 p.m. So I've got to, it says given the P wave and arrival times, subtract them and then use the paper method. So I will subtract 0, 0, 5 minutes, so it's going to be 5 minutes. So now I'm going to take a different side of my paper because I don't want to get confused with those lines. I take my piece of paper, I line it up pretty much next to the travel time side. I do 0, and then I do 5 minutes. Okay, so 0, 5 minutes, and then I'm going to keep that bottom one on there, and I'm going to slide it up on over. Oops, I went too far. Oops, way too far. They look like they line up right about there. So then I'm going to follow it down. Remember, these go up by 200s. So I've got, silly tripod, you're getting in the way. 3,200, 3,400. So 3,400 kilometers. Did I come out to that? 3,300. It's close enough. You can be plus or minus 100 to 200 kilometers sometimes with these. That's okay. So that's given to find the distance if you're given the P and the S wave arrival times. All right. So if you're looking for the distance and you're given the origin time, so the time it started, and the P wave or S wave arrival time, you hit that P wave or S wave. So if you're given the P wave, you hit the P wave line. If you're given the S wave, you hit the S wave line. So all in all, given the origin time and the wave time, hit that wave. So what that means is this. The earthquake occurred at 6 p.m. and the P wave arrived at Cambridge at 6:10. What's the distance? Well, I need to figure out the difference in the time it took for the P wave to arrive and the time it started. So how much time was between 6 and 6:10? It was 10 minutes. So now what I need to do is I need to go to my earthquake chart. I go to 10 minutes. I follow it across until I hit the P wave, and then I follow it straight down to see the distance it was far away. Try not to draw on this because you're going to need to use this over and over again. And that was about 6,600 kilometers. I'll check my answer. Did it? I wanted to say, well, bam, and it didn't come out correctly. So let's try this one. The earthquake occurred at 4:10. So that's the origin time. That's what time it started. And the P wave arrived at Cambridge at 4:18. So between 4:10 and 4:18, it was 8 minutes. So what's the distance? Well, I was looking at my P wave. So that means I need to go to my reference tables. I go to 8 minutes. I follow it across until it hits the P wave. And it kind of falls halfway between these two lines. So I'm gonna follow it down, and it looks like it's like between 4,600 and 4,800. So I might say it's 4,700 kilometers. Look at that, 4,700 kilometers. Good. So now, the earthquake occurred at 2:30, so that's the time it started. And the S wave arrived at Cambridge at 2:37:20. Holy moly, we're getting into detailed times here. So I'm going to write this one down at 2:30, just so that I don't get things mixed up. So then we have 0, 2, 7. So 7 minutes and 20 seconds between the time that it occurred, that it happened, and when it showed up at the, in this case, it was at the S wave. So it's 7 minutes and 20 seconds. So I'm gonna go over here, 7 minutes, 20 seconds. I hit the S wave in this case, because that's what it told me. Follow it down, 2,000 kilometers. There's the right answer. And then the last one we have to do, this one's also hitting the S wave. So at 11:31 and 20 seconds and 11:25, so 0, 20, so 31 and 25 is 6 minutes. So 6 minutes and 20 seconds. So in this case, again, I said I have to hit the S wave. So I go to my handy dandy reference tables. I go to 6 minutes, 20 seconds. I'm hitting my S wave. Uh-oh, it's falling in between. So I've got to follow it down. It's halfway between 1,600 and 1,800. So I'm going to say 1,700 kilometers. And I'll check my answer. Perfect. All right, so that's if you were finding the distance and you were given either the P wave arrival time and the origin time, or the S wave origin time and or S wave arrival time and the origin time. Okay, so now to find the origin time, the time the earthquake actually started. So if you're looking for the origin time, so when the earthquake occurred, use the distance given to hit the P wave or S wave, depending on what the arrival time you're given in the problem, and then you subtract it. So it's very similar to what we were just doing. You just now have to kind of subtract the time in order to figure out what the answer is. So the earthquake epicenter was 3,000 kilometers away. The P wave arrived at 3:07 p.m. So what you have to do is your 3:07 p.m. I have to figure out the travel time for the P wave. So I have to go to 3,000 kilometers, and then I go up here and I follow it. I go to 3,000, I follow it up until it hits the P wave, follow it across. It's 5 minutes and 40 seconds. 5 minutes, 40 seconds, of which we are going to have practiced how to subtract time the right way, so you will be able to do this correctly. But I'm going to do a quick rundown. For borrowing 1 minute over here, we have to translate that minute into seconds. So 60 minus 40 is 20. 6 minus 5 is 1. So the earthquake happened at 3:01:20 p.m. And there's my right answer. So again, the next one, the earthquake epicenter was 6,000 kilometers away. We hit the P wave that arrived at 5:10:20 p.m. So now we have to go to 6,000 kilometers, because if you know the distance, you know the travel time. And if you know the travel time, you know the distance. In this case, we know the distance was 6,000 kilometers. And we see that it's kind of halfway in between 9 minutes and 20 seconds and 9 minutes and 40. So we're going to say that's 9 minutes and 30 seconds. And then we're going to subtract these again. Again, I'm going to have to borrow 9. So now that I have 20 here, I have to add that to the 60 seconds. So really it's 80. So 50. So it happened at 5:50 minutes. And check your answer. And that's close enough because that's about 10 seconds off. Okay? So the earthquake epicenter was 3,600 kilometers, and the S wave arrived at 6:22:40 p.m. What's the origin time? So the earthquake's epicenter, we know the distance, and now we're hitting the S wave this time. So we've got to write down 6:22:40. So now I've got to hit the S wave, so 3,600. Following it up until it hits the S wave, follow it across, 11 minutes and 40 seconds. 11 minutes and 40 seconds. Now you have to subtract the 2. So that happened at 6:11 on the dot. And we should be putting PM, even though it's not written here, but you got 6:11 p.m. Good. Same one here. The earthquake's epicenter was 800 kilometers, so this one's actually pretty short. And you have to hit the S wave. And it arrived at 12:17 p.m. And what's the origin time? So I'm going to hit 800 kilometers all the way down here, and I have to hit the S wave, this one says. I'm going to follow that up 3 minutes and 20 seconds. So I'm going to subtract because I'm still finding the origin. The origin is going to be that earlier time. I'm gonna have to do borrow, 16, 60, 40, 13, 12, 13, 40 p.m. Check my answer. All good to go. So now that was to figure out the origin time. Now I just have to figure out the travel time for the next 1, 2, and then we'll figure out arrival time after. So if you're looking for the travel time and you're given the distance of the S wave or the P wave arrival, hit the P wave or the S wave depending on what you're given. So given the distance and the arrival, hit the P or S wave. So the distance is 2,500 kilometers and the P wave arrival is at 2:30:10 a.m. So really, you don't need this information in order to answer what the travel time is. All you need to know is the distance, because if you know the distance, you know the travel time. So 2,500 kilometers, 2,200, 2,400, 25 is right in between. So that goes up to being about 4 minutes and 50 seconds. So I'm just gonna write this down, 4 minutes and 50 seconds, but I gotta write it down the correct way. Check it, there it is. This person, we did not write that the right way. All right, now the distance, so they gave you extra information here. We really don't need to know this time. We just need to know the distance in order to figure out the travel time. So 4,200 kilometers. So 4,200, gonna follow that straight up until I get to, it kind of looks like 13 minutes and 10 seconds. I'm gonna write that down. So 13 minutes and 10 seconds. Check my answer, 13 minutes, 10 seconds. Good. And then the last thing that we need to check is the arrival time. So if you're looking for the arrival times and you're given the origin time and distance, hit the P wave or the S waves and add. So given the origin time, so the time it began, and the distance, you find the travel times and then you figure out and add it to it. So if the earthquake epicenter distance is 2,300 kilometers and the earthquake origin time was 7:15:40, what is the P wave and S wave arrival time? Well, the P wave at 2,300 kilometers, 2,300 P wave, it looks like it's 4 minutes and 30 seconds. So 4 minutes, 30 seconds. 0, duh. Now you can't have 70 here. You only can have 10 through 59 or 0 through 59. So it's not going to be 70, it's actually going to be 10 because I'm gonna take 60 out of this and add it over here. So that's gonna be 16 and 4 is 20. So it happened at 7:20:10. Now, that's when the P wave arrived. So for the S wave, I've got to do 7:15:40 because that's the origin time. I have to figure out the S wave travel from 2,300. That's going to be about 8 minutes and 10 seconds. 8 minutes, 10 seconds. Add them. So 50, 3, so 23 and 7. So it happened at 7:23:50 for the S wave. And I'll check my answers. 7:20:10, 7:23:50. Good.